So, last time we were working on worksheet 2. So, we will continue that, and then we will also talk about how to use the equations that we used last time for vertical motion. So, we were talking about horizontal motion so far. Today, we will also talk about vertical motion if the time permits. Okay, but we will first look at worksheet 2 questions. We finished up to number 5 last time. So, we had Vx or Vt graph, and then we were asked to find the position of the object at 4 seconds. So, let me summarize here how we find the things from graph, okay, and then you can use that for your problems. So, if you are given position versus time graph, meaning if you are given x versus t, then you can find slope, okay, to find velocity. Likewise, if you are given velocity versus time, then you find slope to find the acceleration. Okay, so you are given velocity versus time. If you have a linear graph here, okay, if you have a linear, let's write here. So, linear graph, then you will get constant constant velocity. Okay, so if for this kind of graph, you will get velocity with a constant value like that. Okay. If you have a graph that is nonlinear, something like this, nonlinear, okay, this is quadratic, then you will get linear graph like that. Okay. So, this means this green one means its velocity is changing with time. So, velocity is slope of this graph. You see the slope is changing, right. So, you draw a tangent line denotes the slope. So, that is the slope. So, slope at this point is a tangent line like that. Slope at this point is a tangent line like that. A slope here is tangent like that. A slope here is tangent. You see here these red lines are getting steeper and steeper. Okay, there is increase in the steepness of the graph, and that's what this is. Okay, so this represents the steepness of xt graph. So, this tells us that the steepness is changing, whereas for this blue one, the steepness is constant, it is same throughout. So, this tells us that constant steepness of xt graph. Okay. So, same thing with Vt graph. So, if you have a linear Vt graph, something like this, then its acceleration would be constant. So, acceleration is the steepness of Vt graph. So, we have same steepness. So, you have that. Now, if the steepness is decreasing. So let's look at another case. Let me just erase this one. Let's see how to erase that. So I will erase this one. So we saw the increasing steepness, but sometimes the steepness may be decreasing. Okay, let's see the case where the steepness is decreasing. Here, so if you see a graph like this, that's the decreasing steepness. Okay, in this case, this is x versus t. Your graph for v versus t would look like decreasing means the steepness will be negative. So your velocity will be down here, okay? Negative slope of xt. Likewise, if you have a graph like this, okay, it's a non-constant, non-linear graph. Okay, if you have a graph like this, so what do you think about the steepness of the graph at each and every point? So let's look at the steepness here. At this point, that's the steepness. At this point is the steepness. That's the steepness at this point. That's the steepness at that point. Steepness at that point. What is happening to the steepness as you go along the duration of t? Is it decreasing? So steepness is decreasing, right? It's getting less and less steep. So that means for this green graph, my graph would look like that. Okay? Steepness is decreasing. So let's answer number 6 with this concept. The slope at a point on a position versus time graph of an object is the object's speed at that point, the object's velocity at that point, the object's acceleration at that point, the distance traveled by the object at that point. I just gave you the concept. So what's your answer? A, B, C, D. Why is it not B? So position versus time, you find the slope, you get velocity. So what's the difference between speed and velocity here? When you have a graph, does the slope of the graph gives you speed or velocity? Why not speed? The difference between speed and velocity is yeah. So yeah, you're pretty close. So speed, velocity is speed, which represents the value or magnitude, plus direction. Okay. If you know both the magnitude and direction, then that's velocity. So when we are finding the slope, this tells us both magnitude as well as direction. The direction is given by the sign. So in this case, the slope is negative. Okay. That means it's going backward. Okay. If it is positive like that, it's going forward. So you can find both speed and direction with the graph. So graph gives a graph gives us velocity. Okay, let's look at number 7. Let's get rid of that. So when do objects 1 and 2 have the same velocity? At some time before t naught, at t naught, exactly at t naught, at some time after t naught, either or both A and B, or never. At some instance before? How do you know that? Yes, exactly. Yes. So we know that speed is a tangent of xt graph. So the steepness of this tells us the speed. Okay, it's steepness. Now find the steepness at different points on this graph and see which one will be same as the steepness of this one. That would be the point where they have the same speed. Okay, so the steepness here is that, 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 that. So is this steepness same as the steepness of this one? That's the steepness. That's the steepness. Are they same? Same steepness, right? So that's the same steepness. When the two lines are parallel, they have same steepness. Steepness means also slope. Okay, they have same slope, same inclination. That means this is the point where this point and this point. Okay, straight line. So let me draw a straight line. This is the time at which this steepness and this steepness are same. Okay, so that's the time, and that is before t naught. So t naught is here. So that means our answer is A. Same kind of question for 8. So you should be able to answer that after answering this one. So what's your answer? Do P and Q ever have same velocity? If so, what time or times they have the same velocity? Again, you need to look at what time they have the same steepness or same slope. Yes. So at 2 seconds, they have same velocity. Okay. Now let's look at number 9. We talked about this a little bit last time. So let's say you are given velocity versus time or acceleration versus time. So how do you find displacement from this graph? Okay. So we want to find displacement from this graph. That means going one step backward. Okay. In the previous one, we found position from velocity from position. Now we want to find either position or displacement from velocity, just opposite to the previous one. Here we want to find velocity from acceleration. Okay. So the way to find is, if you have a graph like this, you find area under that graph. Okay, area under the graph or the curve. That gives you the displacement. Or you can also say position. Likewise here, if you have acceleration versus time, you want to find velocity, find area under the curve. That gives the velocity. Okay. So for 9, you need to find the area under that line from 0 to 3 seconds. So what's the area under that line from 0 to 3 seconds? What's the area of a triangle? Oops. So I'm just asking, yeah, so that's the right answer. I'm asking what's the formula to find the area of a triangle? Yes. So if you have a triangle, its area is 1/2 base times height. Okay. So in this problem, in this question, base is 3 seconds, height is 12 meters per second, and then we also need 1/2 here. Let's see, is that 12 height? Yeah. So 3 times 12 is 36. 36 over 2 is 18. Okay. Second and second cancel, so you will have meter. Okay, so let's look at number 10. A car moves along a straight stretch of road. The following graph shows the car's position as a function of time. At what point or points do the following conditions apply? The displacement is 0. Where is the displacement 0? So we have a graph like that. So this is position, that's time. So obviously the displacement is not 0 at point A, because it goes from this point to this point, sorry, no, upward. So it goes from this point to this point, that's the position. Okay. As the time passes, the object or the car would be at this position. Okay, that's the position. So it's not 0 here. It's not 0 here because this value will give you where the car would be at this time. Okay, so that's the position is not 0. How about C? Also for C, the position is non-zero. Displacement is not 0. How about that point? Is that the 0 displacement? Huh? Yeah, D, right. I meant to write D. So that's not C, sorry. I repeated the same letter. So that's D. So D, yeah, D, at D, the displacement is 0. Where is the speed 0? Again, speed is slope of this graph. Okay, so where is, at what points the slope of the graph is 0? See, in this region there is no 0 slope. In this region also there is no 0 slope. How about here? Slope means a tangent. Okay, draw a tangent line. Is that 0 slope? Whenever you have a flat line means it's a 0 slope. There is no steepness. Okay, 0 steepness. Slope and steepness are same thing. So this has some steepness, this has some steepness, but this is there's no steepness with that. Okay, so that's B. Here also, down here, it's a flat line, so there is no steepness. Okay, down here. So that's also the 0 speed point. Speed is increasing, or steepness is increasing. At what point the steepness is increasing? A, yeah. Wait, steepness. No, not A. So along this curve, let me cross that out. Look at the points in this region. Look at the steepness. So here it's very, very steep. The steepness is gradually decreasing. Steepness is decreasing, and it's flat. So when you go from this point to up this point, the steepness is decreasing. Okay, it's getting less and less steep. That means the steepness is decreasing at point A as you move up. How about from B to D? Okay. So, here is 0 steepness, no steepness, and then gradually the steepness is increasing, getting steeper and steeper, steeper and steeper, and here maximum steepness. So, that means the steepness is increasing along this curve. Okay.
So, for the last question then, for decreasing, would it be A then?
Yes, exactly. So, for D, A would be the point where the steepness is decreasing, and for increasing steepness it would be C. Okay. C as well as D. We cannot say D because D is something called inflection point, where the steepness flips. Okay. Up to point D, the steepness increases. So, at D you will have maximum steepness, and then from D onward the steepness also decreases. You look at this line here. So, the steepness is now decreasing, 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 and then flat. Okay. So, this is increasing slope, this part is decreasing slope, and this part is also decreasing. Okay.
It's not factoring the sign of the slope, or just the magnitude?
Yeah, this is asking about the magnitude, right? Magnitude of the slope. Yeah, because it's asking for the slope. So, speed. Speed means you don't need to worry about the sign. Okay. So, let's look at number 11. A particle has velocity as it moves from point 1 to point 2. The acceleration is shown. What is its velocity vector as it moves from point 1 to point 2? Okay. So, what's your answer? Give me whether it's A, B, C, or D. So, when you see this kind of arrow on the ladder, that means it's a vector quantity. Vector means it has both magnitude and direction. B. Yeah, B is the right answer. Why is it B? So, when right. So, when V and A are in same direction, it's speeding up. Okay, this means speeding up. When it's speeding up, the velocity vector would increase. Okay, so V increases, which is not the case here. So, here the case is V and A are in opposite directions. That means it's slowing down. We saw this rule last time. Slowing down means if you have this much velocity to begin with, then later on you will have a shorter vector or small value. Okay, so that would be the velocity later. So, you need to think about which arrow is smaller than or shorter than the given arrow, and we see it's 2. Okay, or I mean B. So, B is the right answer. Okay, let's look at number 12. So, read the question. We are given a ramp, a flat surface, and then a ramp, and then a flat surface. So, sketch graph of velocity versus time, and then in the same graph also sketch acceleration versus time. You guys want to try that? So let's first draw the velocity versus time graph. So on the first part, flat part, the velocity would be constant, right? It will just roll, assuming that there is no friction, it will just roll at constant velocity. So if we have a constant velocity, how do we represent that here? With a flat line? Constant means the velocity is not changing, so it's a flat line like that, right? Maybe I should draw a little bit shorter. Okay. And then when you roll it down, what happens to the speed or a velocity of the ball? Will it increase or decrease? It will increase, yeah. It will increase linearly. Okay. It will increase like that. It should be a straight line, but I didn't draw it straight. And then we have another flat part, and along that flat part, the velocity will be constant again. Okay, so we have a constant velocity again. So that's the velocity versus time. And then next thing is we need to draw acceleration versus time on this and on that same graph. So for acceleration versus time, on this part from here to here, acceleration is the steep slope of v. Okay, slope of v. So what can you say about the steepness here? How steep is the curve here? No steepness, right? So that means zero steepness. No steepness. How about the steepness here? Is it changing or same from here to here? Do we have same steepness or the steepness is changing? Wait, is it changing? Steepness? Slope? Same slope, right? Same steepness. Steepness means, let's say you have this kind of plank or some kind of slanted surface. Is the angle changing? You have the same angle, right? Let's say 30 degrees. So same steepness. No matter where you measure the angle, you have the same angle. So same steepness. So same steepness here. Constant steepness. That means acceleration would be a constant value, okay, from here to here. So that's our acceleration from here to here. And then how about the steepness here? Do we have any steepness here? Zero, right? So from this point to that point, the steepness is zero. So flat means zero steepness. Okay, so this red one is the graph of acceleration versus time, and the blue one is velocity versus time. Number 13. You should be able to answer number 13. So the motion diagram shows a particle that is slowing down. What is the sign of the acceleration? Yes. So since the velocity is negative, v is negative, and when the object is slowing down, v and a are in opposite direction, okay, for slowing down. That means a must be positive. So you have 4 different diagrams. Number 14. Which motion diagram corresponds to positive acceleration? So this sometimes it's obvious just by looking at the direction. So when something is pointing to the right or towards positive axis, it's positive. Okay. When something is pointing to the left, it's negative, no matter what that is. If a velocity is pointing to the right, velocity is positive. If the position is pointing to the right, if you are moving to the right, your position is positive. if you are moving to the left, your position is negative, or your displacement would be negative. Okay. If you are moving to the left, your velocity would be negative. So negative means moving to the left, or pointing to the left, I should say. Positive means pointing to the right. So in this case, for A, bunch are pointing to the right and bunch are pointing to the left, so that's not right. The upper arrow is the acceleration. Okay, the bottom one is position or displacement. So number B, part B, again some are pointing to the left and some are pointing to the right, so that's not correct. C also, some are pointing to left, some are pointing to left or right, so that's not right. So on D, all the arrows are pointing to the right, so that means the answer is D. Okay, so for D, acceleration is positive. 15. Okay, I will let you guys figure this out. Okay, so I want you to give me the answer for number 15.
How would you differentiate between C and D?
How do you differentiate between?
Between C and D, since they're both going in the same direction.
Oh, one is slowing down, other one is speeding up. If the arrow is getting shorter, it's slowing down. If the arrow is getting longer, it's speeding up. So what's your answer? Okay, so let's see if that's the right one. So in this one, velocity is positive. Here in this one, velocity is positive. In this one, velocity is negative. Going on the left side, it means negative velocity. Going to the left means velocity is negative. Okay, so that's the direction of velocity. And then here, it's slowing down because speeding up because the arrows are getting longer and longer. So speeding up, that means acceleration must be positive. When it's speeding up, velocity and acceleration have same direction. This one is slowing down. So when it's slowing down, acceleration and velocity have negative opposite signs. That must be minus, negative. Here it's speeding up. Arrows getting longer means speeding up. Okay, speeding up. So what should be the direction of acceleration here? Speeding up means acceleration and velocity would have opposite or same direction? Same direction. Here you see the gap is increasing. Oh, my mistake. My mistake. My mistake. This is slowing down. Okay, this arrow, size of the arrow is decreasing. So less and less distance covered in the same time interval. So that means A would be positive. Okay, slowing down means opposite directions. Here it's speeding up. So acceleration would be negative. So you can now answer which arrows represent the negative acceleration motion. This one and this one, B and D, right? B and D. Okay, let's look at number 16. A car slows down while moving away from the origin. What do the position and velocity graph look like on the right below? So one thing you can tell here is its position should be positive. Okay, it's moving to the right. So that means you can eliminate the first graph, graph A. On graph A, let me copy and paste the graph. Okay, so here, so this curve is moving down. That means your x value would be getting x value is getting negative as it moves down. So this is not right because the car is moving to the right, so it should be positive. So this is fine. That's fine. That's fine. Now let's look at the speed. So what can you say? Velocity. What can you say about the velocity? It slows down. Slowing down. Slowing down means stiffness is decreasing. The velocity curve has less and less speed. Okay. So which one would be the right one? Here, this one is the stiffness is increasing as it goes down. So that's not right. Sorry, yeah, so stiffness here is increasing, so that's not right. How about this one? The velocity is decreasing. So the velocity yeah, so this also cannot be true because you have a negative velocity here. So something below 0 means it's negative, okay? V is negative. Negative velocity means it's moving to left, which is not true in this case. Okay, so that's not true. That's not true. Again, here the velocity is negative, which is not true. Here we have positive velocity. That means it's moving to right, and also the velocity is decreasing. See, the velocity is going down, 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 and eventually 0 velocity. Okay, so that means slowing down and moving to right, which is the thing you see in the picture or question. Okay, so let's look at number 17. So let's think about number 17. First, look at the position versus time graph and see which ones you can eliminate. So the condition here is it's speeding up and moving to left. Okay, moving to left, speeding up. Moving to left means the velocity must be negative. Okay, this thing implies v is negative, so it cannot be positive. So let's see which ones the velocity is positive. So this is not right. So velocity is positive there. This is not right. Velocity is positive. So either this one or this one. And it's speeding up. Speeding up means, so when you see a steepness like this is speeding up. Okay. No, sorry. Let's see. When you see steepness like this, okay, in the negative axis, so here it's 0, and going down means it's going to the greater value. Okay, greater value means it's speeding up. Moving towards greater value means speeding up. Okay. Here it has this speed, and see it's moving towards the smaller value. Okay, eventually the velocity here would be 0. So what can you say about that? Slowing down. Okay. So between C and B, which one satisfies our picture? It says speeding up, so that means this one satisfies our condition. Okay, so speeding up and moving to the left is represented by this graph. Okay, let's look at number 18. I think you guys should be able to answer that. Okay, so tell me what's the answer. We already saw this in the previous question.
Maybe negative.
Yes, negative, because the car is moving to the left, so velocity is negative. If it is speeding up, acceleration should have the same direction as the velocity. So negative. Number 19. So let's look at number 19. Think about it. 19 is a similar kind of question as the one we just did. So in this case, velocity is negative because it's moving to the left, and it's speeding up, so acceleration would also be negative.
On number 19?
Oops. Oh, sorry, I was looking at number 20. My mistake. What happened? Okay. So I was looking at 20. Sorry, I will repeat this again. Let me erase that. I looked at the wrong question. So number 19, slowing down. So car is moving to the right, so velocity is positive. It's slowing down, that means acceleration should be opposite, so negative. So which graph satisfies these two conditions? Yes, C. So this is the acceleration that is negative, okay? Negative acceleration. So yeah, so this would be speeding up because it's going from lower value towards higher value, so speeding up. This is slowing down. So this cannot be true. Acceleration is not positive. This is also not true. So this one. Okay, number 20. So think about number 20. Actually, it's the same graph. So what's the sign of velocity? Positive? Negative, moving to the left. And it's speeding up, so what should be the sign of acceleration? Negative. Speeding up means they will have same direction, same signs. So acceleration negative means that's not true. That's not true. Velocity is negative, so this is not true. We have positive velocity here. So this one has negative velocity, negative acceleration. How about A? So here we have positive velocity. Okay, anything above this axis is positive. Anything below is negative. So if it is negative, then it should be below the axis. Okay, the last one. So which graph represents velocity versus time corresponding to the given acceleration graph? E? Did you say E? So this is negative. So the velocity corresponding to this, so when you should have negative slope, okay, negative. This is positive slope of VT graph. Because this represents the slope of the VT graph. And A, what's the slope of the graph on A? 0, right? It's flat. So A is like that and like that. So this is 0 slope. Okay, so A is 0. 0 slope means A is 0. How about B? Whenever you see something like that, so that's constant slope. Okay, just one slope. Something like this one is also constant slope. So it's either D or E. It cannot be D because the first part has positive slope. Okay, so here this is positive slope. Okay, that means acceleration is positive, and this one is negative, which is not what we see here. So we have negative and positive, but here we have positive and negative. How about look at E? We have that and that. So this one is negative slope. This is positive slope, and the slope is constant. Okay, this is constant. This is also constant. So if I have to draw acceleration versus time, I have negative constant slope, so negative constant slope, and then it jumps from negative constant slope to positive constant slope at that point. So then I have positive constant slope. Okay, so that's that, and then that's that. Okay, so that's worksheet 2. So please complete that. We have 2 more minutes left. I just want to review, give you idea like what we will be talking next. So last time we talked about equations of motion. So we saw 3 equations. A is equal to Vf minus Vi over T. Delta x is equal to V final squared minus V initial squared over 2a, and then delta x is equal to V it plus 1/2 at squared. Okay, so this is for horizontal motion. Now next time we'll be talking about vertical motion, horizontal. So in vertical motion, because we want to differentiate the 2 motions, so for horizontal, I don't know what happened. We'll be using x to represent the horizontal motion. Okay. For vertical, we'll be using y, okay, instead of x. So here we will be using delta y, same equation but same different symbols. Okay, Vi squared over 2, instead of a, we'll be using ay. Okay, here we will be using ax. Here we will be using delta y. This is the vertical height or vertical displacement. Vi t plus 1/2 ay t squared. And for this also we may use, we'll use in the next chapter, but for now we'll not use that. So later on we'll be using y here also, but for now it would be obvious when we have delta y here. So ay is Vf minus Vi over t. Okay, so this is what we'll be talking next time. Okay, so that's all for today. If you guys have any question, I can answer your question. Otherwise, yeah,
For worksheet 2, are we just going to submit that on?
yeah, grade scope. Yeah, just like last time, you submit it on grade scope.